Okay, basically, I'll briefly say how we do powers or indices of fractions, and then we'll answer the questions. But then I'll go on to explain why this is the case. Essentially, if you do, let's say, a to the power of 1 over b, it means, or let's say 1 over n, because it's going to be easier to pronounce, it means the nth root of a. Okay. Now, in other words, this means the square root of 100. When we write, we don't actually need to write the 2 in that case. So that would be 10. And the other thing, the other rule that we want to be aware of is that if I did a to the power of b times c, then that is the same as saying a to the power of b all to the power of c, or if you like, it's the same as saying a to the power of c all to the power of b, because obviously you can multiply b and c in whatever order you want. So that would mean that I could say this is the same as 125 all to the power of a third. Oh, wait a second, we don't want brackets there. All to the power of a third, and all of that is squared because 1/3 times 2 is the same as 2/3. And so if we know, and we know that if we do a fraction like that, then that would just mean that it's the cube root of 125, and all of that is going to be squared. And that would work the same as if I put the square inside the bracket too. But you'll probably find it's easier to think about it like that in this case. So first of all, let's just check the front of the paper. It's a non-calculated paper. I had a feeling it might be. So 125 all squared, I believe. Cube rooted. I believe, yeah, that's going to be 5 because 5 squared is 25, and then times it by 5 again is 125. So that's going to be 5. Cube root of 125 is 5. We need to square it. So that gives us 25. Okay, so those are the answers to the questions. But now let's try to understand. Let's try to understand both of these rules. And let's do this one on the right first because it's easier. Why is it that when I multiply the powers, I end up getting this situation? Well, if I had, let's take an example of, I'll keep a as just a, and we'll say it's a squared all cubed. Well, that would be the same as saying a times a all cubed. And a times a all cubed is the same as saying a times a multiplied by itself 3 times. So it's a times a times a times a times a times a. And as you can see, there are now 6 of those a's, which is therefore a to the power of 6. So with a little bit of playing around, imagining doing this with different numbers, you'll realize that you always just multiply these two numbers. Okay, I won't explain that any further for this one. Next, I want to look at this rule. So why is this like this? So this is a little bit harder. This is probably the hardest of the rules to sort of explain. But let's imagine that I said that a to the power of a half is okay. Let's a to the power of half multiplied by a to the power of half. We know is going to be equal to a to the, I'm going to use another rule. There is another rule. Okay, let me explain another rule first before I do this. A squared multiplied by a cubed is equal to, you may know this rule already, a to the power of 5. I'm just going to state that rule. I'm not going to prove it. But what you do is you add the powers, okay? Now, using that rule there, I can do a to the power of half multiplied by a to the power of half would be equal to a to the power of half plus a half, which is a to the power of 1, which is just a. So, let's just shrink this. So basically, as you can see, a to the power of half multiplied by a to the power of half is just squared. So that's equal to a. I could have actually used this rule then, couldn't I? Never mind. So now I can square root both sides. So if I square root the left, it just cancels out this square, leave me with just a to the power half. I square root the right, and it leaves me root a. And if I did that with, if it was instead of that it was cube, then I would cube root both sides, and it was the same would work. All right. So I'll just stop that video there, and I'll leave you to watch it and have a think about it.